Hi folks, and welcome back to Math with Captain Rod here. I'm making this video here to help demonstrate an example out of section 4.4 here. We're going to take a look at number 2, and this section is about applications of quadratic equations. So the example we're going to look at here, it says, let's see, the height of a triangle is 3 meters less than the base. The area is 20 square meters. Find the length of the base and the height of that triangle. So any of these problems about geometry, always start by drawing yourself a picture here. So we got some sort of triangle. Let's start with that. All right, this length right here is what generally called the base here, and then this distance right here is called the height. Now, let's identify the unknown. In this case, both of these, we don't know the base or the height. You typically start these problems now by defining some sort of variable. I could say maybe let x equal the height or the base. It's not going to matter. I'm going to go ahead and say let x equal the length of the base. So this is now, this distance here is now x. Now, this first sentence says the height of the triangle is 3 meters less than the base. So now if x is what I'm calling the base, then the height is x minus 3, because it says 3 meters less. Now, had I called this the height, x, then the base would be x plus 3. But, and it won't matter which we do here. All right, so now, let's see. Next, it says the area is 20 square meters. So hopefully we know this, but if we don't, we can look this up. When you calculate the area of any triangle, all right, that's the surface area here. The area of a triangle is equal to 1/2 the base times the height. So in our example, the area is 20 square meters, and that's going to equal 1/2 the base, and I went ahead and called that distance x, times the height, which is equal to x minus 3, and this will be in square meters. I'll go ahead and put the units over here. It's okay if you didn't want to write the units in this, as long as you're consistent with the units. If you just wanted to write 20, keep in mind that these are in square units, and then this is in meters, and this is in meters, so this would also be in square meters. So I'm going to go ahead and rewrite this equation now without my units here. We got 20 equals 1/2 x times x minus 3. All right, so the next step is to solve for x. Now, we could distribute this 1/2. However, I'm not going to. I think this will be a little cleaner if we go ahead and just multiply both sides by 2, because that will get rid of this 1/2. So the new line, and I think I'll write this over here, running out of room, is going to be 40 equals x times x minus 3. Now, you might be tempted to say, well, maybe x is 0 or x is 3. That only works when you have a 0 on this side, right? So you can't solve it yet in this form. This is going to have to be distributed. And we do this product, we get x squared, and then this product minus 3x. Now, recognizing we got a quadratic equation because this is second power, we're going to want to decide how to solve it. Now, how you solve these, if you've paid attention, you've got like completing the square. So a square there. You've got factoring and the quadratic formula. If you're doing completing the square, you want this number over here, and you start working on completing the square on the right. If you're going to try to solve it by factoring or the quadratic formula, you want a 0 on one side. My favorite method is the quadratic formula, if it can't be factored easily. So I'm going to go ahead and put a 0 on this side by subtracting 40 from both sides. All right, this is now 0. Equals x squared minus 3x minus 40. Now I'm going to take a moment here and just see if I can't factor it here. I'll think about that 40 for a moment here. 40, let's see, factors of 40. 40 and 1, 20 and 2, 8 and 5, and I'm taking notice 8 and 5. They differ by 3, and I'm looking like here going, that's kind of curious. So I'm guessing this thing's probably going to factor. So instead of using the quadratic formula, let's try to factor it. All right, the lead terms have to multiply to x, so this is going to be x and x, no doubt. Factors of 40, let's see, 8 and 5. Now you'll notice that this is minus 40, so one of these has to be negative. Probably this one because of the minus 3. I'm going to kind of double check, just check the outer and inner terms. minus 8x plus 5x. There's my minus 3x, and then the last term's minus 40. So it's factored. We're good. All right. So now we have the product of two numbers equals 0. Either this one is equal to 0 or this one is equal to 0. Now, if this one were equal to 0, x would have to equal negative 5. However, x is a distance here, right? And distances are not negative. So I'm going to just throw that one out, not worry about that one. If the green one here equals 0, then x is equal to 8. So there's our solution to this guy. Let's see, x is equal to 8. So the base, if I remember right, yeah, x was the base. The base length is 8 meters. And then our height is x minus 3. So our height is 5 meters. Okay. And that's how you solve one of these geometry problems. Now the thing is about these geometry problems, each one is unique. You know, you can have geometry problems about circles and triangles and rectangles and all sorts of different things. This is just one example out of the book. But one of the things you want to do with all of them, draw a picture, no matter what the geometry is, and then label it. Label all the relevant geometries. And then assign a variable. Then see if you can rewrite some of the other factors in terms of that variable. Then try to write some sort of equation relating the variables and solve it. So that's what's common to all of them. I hope that this video helps with this stuff. Have a great day.